So very good morning, and I'm pretty excited for PGConf 2026. Hope you all have a great conference over here. I'm Deepak Mahto, founder at DataCloudGaze. We primarily help a lot of customers move away from Oracle or SQL Server into Postgres. And day in and out, we do a lot of tuning. So this talk is primarily about what are some of the core foundation that we have to build when we talk about query tuning. And in most of the cases, it's not always creating an index or so, but it's having empathy towards Planner to understand how it thinks. And sometimes it is art. Okay? So I'll start with the core framework that we all should follow when we talk about query tuning itself. Okay? So over here, the framework that we have is spread across 5 different layers. Okay? The very first thing is finding the SQL and understanding what it is doing, which is query forensic. And I hope most of you know what is explain analyze. So what it primarily means is explain us how the query is behaving in the runtime as part of different access method that it does. But at the same time, before you do explain analyze, you have to have a way where you can find the problematic query. So finding is also equally important than tuning. Second thing is the planner thinks based on the statistics that you have for a table, for a column, and those all statistics come as part of the statistics portion. So that is primarily the metadata that you have for all of your tables and columns. And that's the second foundation pillar that we have to understand. Third one is primarily your DDL. There's a saying that the query tuning doesn't start when you go to production, but it actually starts when you're designing your databases. It's a day one operation. It's not something that you do on production. So it primarily means that how well you define your data type constraint that have a very important hold on how the planning behave. You'll see some of the example where it use constraint to make a wiser decision for you. The fourth one is query styling. Now, I'm not a big fan of best practices of how to write query. For me, the best practice is where the planner is able to choose the right optimal path. Doesn't matter how you write a query. It simply means that it's not that exist is faster than in or so. We are living in an era where optimizers have evolved a lot. It's not your query styling, but it's how planner thinks about it. That's what query rewrite means. And finally is the version that you are running in GUC and all. Recently, if you follow Postgres version from till 18, you'll see a lot of performance improvement being added, which revolve around transformations, statistics, making sure that Planet itself does a rewrite to have a better output for your query, right? So overall, that is the one. And one tips that I want to give to everyone who is doing query tuning is don't start your query tuning by running analyze on the table that is involved. Most of the developers, when they start query tuning, the first thing they do is they look for the table which is involved in the query and run an analyze. You're actually missing a window to find why your stats are obsolete by running an analyze on top of it. So analyze itself should be a recommendation that should come after analysis. And don't chase a magical index that does all of those. So the point is you don't have to create a covering index to cover a bad written SQL. Okay? So it's all about, so over here I'm not here to give you a tips of what to follow, but to give you a strong foundation on how to think, make it align with how planner thinks, and make sure that you build a strong foundation around query tuning. So let's take a dip on all of those, right? As I said, tuning doesn't start with explain analyze. It starts with what to analyze and which query to look for. And that's a very important thing to do, right? You have to find the problematic query before you start the tuning itself. There's an extension in Postgres available as part of Contrib itself. I hope most of you know PGStat statement. It's one of my favorite extensions. This is something that you should always have in most of the production setup that we are running. It's primarily a flight recorder for all of the queries that it is doing, right? It's an available extension. It's always good to have it. It also has its own configurations. So there's one thing that we always use for a lot of cases, right? Whenever you put your logic in procedural block, it's very hard to find which particular section of the block is taking time. If you look at the configuration, there are options to basically track all the SQLs that are nested within PGSQL, so you can get that as part of PGStat statement itself. You don't need a complex monitoring system to get it, right? A simple configuration can help you understand which portion is taking time. And the best part about PGStat statement is that it gives you an overview of the query before you actually do an explain analyze. So basically, there are different metadata and metrics that is available as part of PGStat statement that give you those insights. You can get to know what is your mean execution time. You can get to know what is your standard deviation around execution. Sometimes it gives you hints around plan films and all. It gives you what IO or pages or buffer the query need to serve the output, which is buffer from disk or from memory. It also gives you some of the stats related to temporary usage that you do primarily for sorting or hashing and all of those. And at the same time, in Postgres 18, there was a recently new metrics added, which talk about what was the parallel worker that got assigned to your query. So there are scenarios where your query runs faster when you're testing it because you get all the parallel worker available. But in a high concurrency environment, you might not get a worker. Your query might not be running parallel, right? So all of those give you a lot of hints before you actually go ahead and look for explain analyze. So it's very important to start from understanding your query from PGStat statement. So this is one of the report that I use, and you will see in some of my slides you have a QR code at the bottom left-hand side. It basically gives you the SQL that I'm using or the blogs for your reference, right? So this is a simple query that gives us what are the top things happening in the database as part of coming everything from PGStat statement. So in case we are analyzing it, it gives you a single window to look at, and you don't have to rely on external tool. PGStat statement itself does for you. Moving further, there is additional extension, which is auto-explain. And as the name implies, it means that it will give you an explanation of your query in terms of execution plan automatically into the logs. So in some cases, you want to enable it, have a log min duration, which says that if a query goes beyond that number, you will log those particular query execution plan into the log. Now, it's up to us on how we want to configure it, whether you want to do log analyze and log buffer. Does all of you know what's the difference between analyze and buffer? Postgres 18 has mitigated it because now by default, if you do analyze, the buffer is part of it. Initially, we have to type 7 more characters to get it out, but now it is available. Okay? So the core idea is that you enable your flag, but whenever you do any change in configuration related to monitoring, there has to be some overhead in production. So I don't recommend setting it as it is. It's up to your overhead, what you're seeing, and then enabling it accordingly. So again, this is in log output that is coming out of a query in the form of how it looked like in auto-explain. So for all my demo, I'm using a blue box, which is a Docker available from Ryan. If you want to know more about it, you can scan the tool that I'm using over here. So it just basically shows how the query looked like as part of the logs that we have. Okay, now let's assume we have found our query that we need to tune. Now it's time to understand and analyze it further, right? So this is primarily some of the gold standard that we have to do, right? So whenever you have any problematic query, you can do explain, analyze, and as I said, buffer is part of that as part of Postgres 18, and you'll see what exactly it is. But analyzing a query, this is the command that you have to do. Just be cautious about any DML that you're analyzing, because explain, analyze actually run those queries. So in case you're running a performance for an update or insert, you have to do that in the transaction. And before the talk, I tried to take quotes from some of the known person in Postgres. So you'll see some of their quotes on what they feel about the query tuning and foundation, right? Now, this is the most important slide and equally more chaotic. Okay, so it's kind of an organized chaos. I want to just showcase this, and you look at each color coding that we have done, and you will realize that to come up with a plan, the optimizer or planner has to go through a lot of depth. We have to choose the join that we should use, which is your join method. We have to choose the access method, which can be sequential scan, bitmap scan, and all of those. We have to basically make sure that my actual rows is very near to my estimated rows. What is the buffer that I need to serve this query? What it means is that if I need to get 1 rows out of this query, how much work the database has to do in terms of touching the pages or memory that you have in your memory, in particular the memory area of the Postgres. And at the same time, what are my filter predicate, access predicate, all of those. But what we do, whenever we do a plan, we look at the bottom, the execution time. We all have to realize that execution time is an outcome of the decision that planner has taken, and you cannot freeze it. It's a range of window that will always come. So don't look at the execution time, start looking at all the data points. And this slide is also important that because we have to have some empathy with planner because the planner has to do a lot of stuff, okay, as part of the decision. Now, this is an overview of what are the typical access methods that you see in the plan. So we have sequential scan, index-only scan, and bitmap scan. I hope most of you know what is sequence scan. It primarily means accessing each and every rel pages, which is the memory portion or the storage for a table, to get the output. And we also have index scan, which means the access predicate is based on your leading column from an index. You start your search from index, and you might come to table for additional information, or you might not. When you don't come to a table, that is called as index-only scan, which means that all part of your query, whether be it at where clause or select clause, is sufficed by index itself. And finally is a bitmap scan. What it does is it tries to combine a set of indexes and create a set of information that it can use in a batch to access all of those from the table. Now, all of this have some red flags and some green flags, right? So if you see anyone doing a sequence scan as part of table, we have to monitor the row filter as part of it. If you see a high chunk of rows is being filtered out, that means that you have to undo a lot of work that you have done. You have scanned the table, but you are removing a lot of rows out of it. Same with index scan. We have to see what is the selectivity or cardinality of the filter. Now, selectivity is a very important component when it comes to choosing an index. At the same time is the correlation. What it means that how order is my table as compared to the index I'm accessing. In some other database technology, it is called clustering. Over here, we call it as correlation, but the concept is same. Then we have index-only scan. It means that whatever you need, we can suffice it with index itself. But there are some more concepts that we'll see, and with bitmap as well. Now, nowadays, doesn't matter how you write your query, be it exists, inner join, equi-join, whatever you do, your query gets transformed to this 3 join only, which is nested loop, hash join, and short merge. What it means that for nested loop, for every row is written from an outer block, you have to execute inner. Hashing means that both the parties who are part of equi-join has to be accessed, and hash table will be created and it gets mapped. Sort merge means that the data are sorted based on joining column, and then they are mapped to produce the output. Now, in nested loop, it's very important that how your inner section is getting evaluated, which means that how many times you are doing it. In nested loop, 2 sequence scan will also be optimal, provided your outer only return 1 rows. Right? So there are cases where sequence scan in nested loop can also be optimal. So the idea is not to say you that this is better than this. You have to understand based on the pattern and access that you're doing for your table join, right? But everyone has its own method to do it. So these are some of the signals that you can look for whenever you look into the plan, right? Some of the signals, as I already spoken about, is looking at the number of rows that you're filtering as part of your access method. Those are some of the tables, columns that can become candidate for indexes. Look for how many buffer reads, either from disk or memory, we are doing to serve the output. If you do millions of buffer just to get 1 row, there's something wrong with the planner or some statistic, right? So we have to look for those. At the same time, whenever you see any sorting happening into the query, we have to understand, does the memory that we provide for the sorting, is it sufficient? Is it not going over the disk? So all of these pointers will give you some of the key drivers to look for. These are called signals, right? So you have to capture some of those. And it's very important to not build your hypothesis just based on one signal. You all saw the plan, right? There are lots of information to evaluate from a typical plan that we see. Now coming to the statistics, right? So statistics are primarily the metadata about table, and it is as good as it was run last time. Now if you look at a simple analyze command that we do in Postgres, there's a flag called as default statistics target. It defines the number of sampling that you do for the table rows. By default, it is set to 300, and we have a constant. What it means that by default, max 30,000 samples are evaluated for a table. And it captures the column level statistics. The job I've analyzed is capture each and every column that you have and get a statistics on top of it. In some cases, for some of the tables, you might want to increase the sampling percentage. So we can increase the default statistics target for a particular column. And if you can look at an example, the sample that now it does to gather the statistics for a table and column, it's more. So it's, in some cases, you want to increase that as well. Now, in most cases, we want to understand that it's not only analyze that play a very important role in deciding what is the good plan. Vacuum also have an equally important role. If you look at this, the example that we have done, there are 3 components that come into picture, which come from PG class in Postgres, which is primarily how much is your rel tuple, what is your rel pages, and how visible every tuple in a page is to your active transaction and future transaction. So this information planner used to decide whether we want to do an additional access method, which is called as heap. So any heap method that you see in the plan, it's primarily referring to the table access. So any additional method that the plan has to do, that add more overhead. So if you look at this example, when we have the rel is visible equivalent to rel is tuple, it means that all of our tuples is visible to any future and active transaction. And if you run a particular plan, you will see heap fetch being 0. So it's a case where it doesn't want to go at table, index itself suffices. But as in when you perform an update, the heap fetch increase because it has to do an additional scan of table to understand it. So the point of both the slide, vacuum and analysis, both of them play an equal role to get you a better plan for a particular table or a query. Now this is an additional overview of what are some of the statistics that we gather. Okay? So if you look at the first table, that is primarily giving you statistics about a table and column. So some of the key statistics that we gather is number of distinct value that we have for a column. What is the correlation of that column in regards of ordering with the table? And at the same time, what is the null fraction for it? A simple question like, if a column is defined as not nullable, what will be the null fraction for it? It will be 0, right? So it means that because we don't have anything. So these are the information that planner used to get a lot of insight. In this case, if you see all of those information is being used to come up with a plan, and you will see all of those signals. So over here, the signal is heap fetches because you're doing a lot of heap fetch as part of serving the query. Now, with this information, there are a lot of strategy that we can build. Now, this is, again, an important component, right? So in mathematics, there's a concept called as histogram, which tell you how much is your distribution for skew value. So there are 2 additional statistics that I didn't cover in previous slide, but I'll talk more about this. Those are most common value and most common frequency. So if you look at some of the columns like status and reason, you can make out that some of those are highly available as part of the whole record that you have in the table. Some are very minimal. And these are the values that plan use to flip based on your access pattern. So if you pass a filter like active, it needs to get a lot of rows because it knows that the most common frequency for that is pretty high. So it will switch to the full table scan, which is sequence scan. But for the same column, if you pass a filter which is less skew, it switches to index scan. So it basically gives that information to planner to choose based on predicate. Now there are some more parameters that come into picture like plan cache mode on how it behaves, because after 4 and 5 execution, it moves to the generic execution. But this is the information that plan used to give you best optimal access path, not based on column, but the distribution of value within that column. So when you use this information, there are lots of things that you can do. What it means that if I have a column which is skewed, why to put that column in index? Because you don't want index access. And that's where partial index kind of concept come in. Now using this simple technique, you can reduce your size of indexes. So if you directly create index on status column to serve cases where you want to have index access, you can get rid of the larger set over there. This all comes as part of your information that you have on the statistics. And this is something that we do with a lot of customer coming from Oracle and all, because over there we don't have a concept of partial index. Now this is an additional tips, right? So in most cases, you might have heard it that my query plan is very different in production, but in lower environment, you're not able to reproduce it. The reason is the data set, the statistics that you have. But from Postgres 18, we can export the statistics from one environment and import it back to a lower environment. So you can get the statistics and get the plan. At the same time, whenever you're doing any debugging and analysis, there are a lot of functions that is available that help you tune some of the values yourself. Now, if you look at the same status column, we have changed the distribution to 50-50, and you'll see the estimation now it's more than what it was before, right? So you can tweak it to understand which particular metrics is causing a flip in plan and all of those. And you can always import it from the other environment. Now, whenever you talk about statistics, it's not always single filter predicate or column that you're passing. It's a combination of it, right? Whenever we look at statistics separately for two separate columns, it will have a very different behavior in terms of understanding. So if you look at the first example, the estimated rows is 9, but the actual rows is pretty high. So the variance between actual rows and estimated rows is pretty high over here. And that's not because the stats is not gathered. It's only because there's no correlation being defined in databases. Now, by defining correlation, we can create additional statistics like n-distinct, dependency, or most common values, which can help you get those statistics. So once you do that, and if you look at your estimation after that, it will become close to it. Again, it's not advised to keep doing it more often for a lot of columns, because any new statistics will add more overhead for analyze. But this is, again, a good indicator for all of those correlated columns. Now, coming to the DDL or the schema design part that we have as part of the databases, right? So it's very important to have a good design as well accordingly. Now, let's look at this example. Now, in this case, you'll see in the plan there's a one-time filter equal to false. Primarily, it means that you're writing a query like select something from some table where 1 is equal to 2. You're actually not executing query, right? And someone said that the best execution is not to do that at all. So over here, the optimizer is able to make that decision because it knows that when you're passing the condition as null, the constraint was defined as not null. So it will not have anything to be served. If you take this example further, there is an additional flag called as constraint exclusion. If you set it to on, and if you have a check constraint on a column which only allow 3 values, if you pass any values which is out of that particular set, it will basically use the same combination. So this transformation planner is able to do because you have created good design with good constraint on top of it. Right? It's very important to not let it rely on the null fraction stats, but also put it on the constraint. Now, taking this example further, right? So this is a very interesting case. Now, if you look at both the queries, right? So this query is being done on a partition table. So over here, event is a partition table, which is created on created date column. And we have both the queries passing filters, doing exactly same thing, but the execution time is very high in the below one. Can any of you think about why that is causing an issue? And these functions are all Postgres provided, part of PG catalog. Yeah, in a way, and it has a volatility function to it. So basically, whatever expression you use or function that you use, it has a characteristic of volatile and stable, and that play a very important role in partition cases or your plan as well. Now, in this case, the clock timestamp was defined as volatile. What it means that it need to evaluate the time for each and every rows being written. Statement timeout, as the name implies statement, the timestamp has to be captured only at the time of execution. Now, to go in much more depth on this, right, this example, if you look at both the plan, so in case of clock timestamp, there were no partition pruning happening. What it means that though you're accessing last 2 days of data based on your expression or filter, we have to scan each and every partition. But if you look at the example below where your function is stable, the pruning is happening. Now, it's not the problem of planner, but it's the way we are putting expression or filter to it, right? So in this case, there's a blog on this as well, but in this case, the whole idea is to make it with a function which is not volatile. Now, there's one more tip that I want to give, right, which I got to know when I was analyzing this one, is there's a concept called as init plan and subplan. So if I put my function within a nested select query, it will evaluate that as part of init plan. So if you look at below plan, there's an init plan that is highlighted, right? That is where your value for that clock timestamp is evaluated. And in the plan, you will see a lot of section where you see never executed. Have you seen this in your plan that you're evaluating? What it means that at the planning time, the planner was not able to prune the partition, but at execution time, it can do it. And whichever portion it was able to do it, it put never executed for that. Okay, so all of these are hints that you have to capture. And I've seen recently for a lot of partition cases, you'll see a lot of performance issue coming up with Postgres because of all of this nature of way it is evaluated. Right? So the goal for partition query has to be make sure the pruning happen either at the plan time or at the execution time. Okay. And this is again the query style, right? Because we have to learn some of the rewrite that we have. So this is the concept searchability which come from Sybase, which means search argument, which primarily means that whether my filter can seek the index. Okay, so the whole concept is don't move your transformation at the column level, move it at the filter level. Whenever you put any transformation at the column level, you actually blind the statistics and also the indexes that are available as part of those columns. Okay, so it's very important to have that concept in mind when you're looking for queries, right? Now, with this example, let's take this also as a consideration, right? Now, in this case, you have a rental ID which is almost unique because your number of distinct is -1, which means that you have only one row for a particular rental ID. If I pass a query where rental is equal to 1, it is rightly able to do an index scan, and the number of rows returned is only 1. But as and when any data type casting happen, like over here you're comparing begin with numeric, you'll see the statistics is very different now. So what it does is, if you look at the last expression where we are doing rental name equal to numeric, database or planner doesn't have any information on the expression. It only have information on columns. It doesn't have. So whenever it doesn't have any information on expression, what it does assumptions. So over here, the assumptions are done based on default equal selection, which are put into the code. It does a 0.5 estimation of the number of rows that is coming. So the point is, whenever you look into the plan, you also have to look for areas where all of this casting is happening and your estimation is way off. And fix is simple, right? So I'm not talking about fix because you all know once you find the problem, fixing it is much easier. Now this is the concept that we use a lot in other database, which is Oracle. I just wanted to use it over here with some reference point as well. So any predicate that you pass in the database, they are categorized as access predicate or filter predicate. Access predicate is one where you can use index traversal to come to table or suffice in index itself. Filter predicate is where you have to always come to table, in some cases index as well. Okay. Now if you look at this particular query and just give 5 to 10 second overview of the plan. It is using index only scan, which is one of the best optimal method. My actual rows is matching with my estimated rows. And at a high level, it looks perfect, right? Do you all feel there is some scope of tuning here, or this is an ideal plan which will approve as optimal? So over here, the point is, the hints is on index search and buffer. Only for index scan, you have to scan almost a lot of index. And in index search, you have probing a lot of it. But if you look closely, just the plan, you cannot make out what is wrong here. Now, what actually help you is to understand how my index is defined. Right? So over here, if you look at the index, the email column, which is highly selective, is the last column in your index. It started with active bool column and traverse the whole index to it. Now, you cannot make it out just by looking at the plan. That's the reason a plan on its own, it's not a good method to analyze it. You have to understand the underlying definition of object also. Now, if you look at the definition of object, now you can know it's email that is causing a lot of filter. I have to tune my index itself or change in a different way. So that's where the concept of access predicate and filter predicate come up. And in some cases, Postgres is not able to make it very obvious for a lot of us. Okay, in common table expression, there's a concept called as clean code. It means that you have to make it more readable. And again, I am of an opinion that why? You have to make it more compatible on how planner works. Now, if you look at this simple query, right, you have a with clause alias, where you're fetching everything from rental, and the filter is passed on top of it. Now, optimizer is smart enough to not materialize it. It internally does a query rewrite transformation, and your query is able to access the index, right? What means that the filter rental equal to 1 was passed to the subquery. Now, if you rely on this, now look at this example. We are doing exactly same, but we are referencing the alias of with clause or common table expression twice. So it is referred twice in the query. Now, this plan is basically not optimal because it has materialized the actual value because it was referred twice, and your query is referring that multiple times. So in short, it was not able to push the predicates, right? So the thought process is clean code is good for a human to read, but when it's come to planner, it can create an issue for it. Okay, so it's like I am talking about a lot of planner, right? So I'm from, the whole point of this talk was to have some empathy with the planner because it does a lot of work. We just have to help it out with a lot of stuff, right? So there's no magic trick over here. And we have some of the settings that you can see over here, which talk about different areas. So these are the settings that you want to set it at a global level, or you want to set it for your specific function as a local method or for a particular session. Some of the settings are important, like work mem or hash mem multiplier, that help you define the memory portion to avoid the dispel. At the same time, it's not advised to keep it very high at the database level, because this is not per query, this is per operation. So if your query is doing multiple sort operation, it will be multiple times. And then we have some more parameter related to, you will see from collapse limit and join collapse limit and gecko. So in a lot of cases, when we move an Oracle view or a query to Postgres, in some cases, the views are very complex. You might have 20 tables involved in the view. In Postgres, there's a limit after which it doesn't do a rewrite or transformation. That limit comes from and join collapse limit. So in some cases, we want to uplift those parameters so that the parsing can take time, but you can tune it further. So those are some of the limitations that we have. At the same time, if you look at max parallel worker per gather, it basically tells that how many worker to assign for some of the access pattern that can run in parallel. A classic example is a sequential scan. Right? So all of those control the execution time based on the worker that is available at that point of time. So in short, I'm not giving the right configuration, but just giving a list of parameters that influence the plan. Okay? And lastly is the statement timeout, right? Sometimes the best tuning is to stop execution after some time so that it doesn't overkill, right? So it's always good to have those barriers over here. Now, this is finally just a fun tip, okay, which I do when I have spare time. So there's a blog called Explain DPS. What it does is it gives you a lot of plans which are available, which people post for query. So just for fun, you can always look at the different plans that you see, because it will give you a lot of perspective to look at as part of the planning and all of those. So finally, what we have done as part of DataCloudGaze, we have created an open source utility called as PGTX plan. The name comes as part of what we have in Oracle. The concept is same, where you bring in the core foundation of what is very important for query tuning, which involve all the top file that we saw, right? Is query forensics, statistics, and all of those in a single window. So your plan is incomplete when you don't give it understanding of how the table is defined, column is defined, and all of it. So PGSQL TX plan make it more easy to have all of those information embedded in a single HTML. Okay, and nowadays it's an AI era, right, where you don't post just the plan to AI, you post the whole information about all the objects involved. So it has a better context to come up with good recommendation. And finally, I just want to summarize the whole mantra, right? So over here, the core thing is to not look for tips, not look for indexes, look for hints that you see in the plan and work on top of it. There can be multiple hints, that can be single hints. It's very important to have those foundation around statistics and all of those. So it starts with finding what you tune, having intent to read the plan with forensics, read your statistics, whether you need to gather it or not, or you're missing something. Also understand what role the DDL play. and also the object, which is from the code perspective, the schema perspective, all of those. And finally, the version that you're running and the parameter setting that you have. Okay, so with that, I just want to say thank you. So that's a core thing I wanted to go.